afternoon, good morning, depends on where you are in the world. You will see a message at the top of your screen saying recording has started, and if you join, you're giving consent. I hope it's okay with you that the meeting is being recorded. It's being recorded so that the people who are not here will be able to follow. I would like to thank you all for finding time to join us this afternoon to participate in this webinar, which is one of a series of webinars organized by the Open for Good Alliance. And in this webinar, we'll be talking about repositories for OpenAI. I would like to invite you to introduce yourselves and tell us which city you're joining us from in the chat function. And hopefully you can now all see my screen, and I see Pretoria, Boston, USA, Washington, DC, welcome, Atlanta, Kampala, Berlin, Copenhagen. For some of you, it's very early in the morning. Thank you for taking time to join us this morning. Especially if you're on, I don't know what it's called, but the middle time. This is really early for you. So welcome, thank you for joining us. Today's session is organized in partnership with Radiant Earth, and it will be talking about the ML for EO Hub that's organized by Radiant Earth. I don't want to say much more about it. You will hear more as we go forwards. I would like to take this moment to invite Jonas to make a few welcome remarks.
Thank you, Elizabeth, and welcome everyone also from my side. My name is Jonas. I'm part of the Fair Forward team, which itself is the proud member of the Open for Good Alliance. It's a 13-member alliance formed back in November last year. And as Elizabeth already said, we are an alliance that focuses on opening up data sets for machine learning. And you can see our mission statement here. It's all about inclusive, localized training data, of course, of sufficient quality so that actually the innovation ecosystem in the countries can make use of that and not depend on data sets, on machine training data sets of the global north. As I said, we have a range of members from across the globe, and today it's really exciting to have the third installment of our webinar session that aims at actually showcasing what are the repositories for open machine training data sets out there that are used. And we want to encourage people not only to get to know them, but also to use them, obviously. So I'm really excited to have such a wide range of people coming in today to listen and to get to know the Radiant Earth ML4EO Hub in more detail. I don't want to say much more than just for you also to have the opportunity to stay tuned. So by having signed up to this meeting today, you will be automatically also sort of in the loop for our upcoming topics, such as the discoverability of gender data. So we'll have a closer look on this aspect as well, and how we can tackle maybe the lack or we don't know, maybe the abundance of gender data that's out there and when it comes to machine learning. This will be our upcoming webinar installment in November, and we'll continue the series next year. So if you want to get in touch, just stay tuned, register, and share the link as well that you have received to sign up for this event. And also, please make sure to visit our websites, since we also have an exciting podcast now, which is in production and which will be published soon. And enough of promoting words, and I would just hand off to Hamed, who will have the pleasure to introduce himself and the Radiant Earth Foundation.
Awesome. Thank you, Jonas, and thank you, Elizabeth. Hello, everyone. So as it was introduced, I'm Alemohammad. I'm the Chief Data Scientist and Executive Director with Radiant Earth Foundation. And today I'm going to talk about Radiant MLHub, which is an open repository, particularly for geospatial machine learning datasets. So let me share my slides. Yeah, let me know if you don't see the slides, but I'll start sharing it now. So first, a quick word about Radiant, who we are. So Radiant is a nonprofit organization based in the US. Our mission is about empowering both individuals and organizations who are working across the development sector to better use machine learning and AI technology on satellite imagery for addressing many international development challenges. And we do this by providing a series of libraries for training data, for models, and also working with the community around standards and tools. So really, our focus is really providing those ecosystem tools so they can be the problem solvers, work on those, and build solutions to be deployed in their local ecosystem. And really, the long-term vision is leveraging these two technologies for a positive global impact. Our role is like a catalyzer in this ecosystem. To start, let me show you, I mean, many of you might have seen this picture about what is a data ecosystem. You can think about data starting from a collection phase, going to a publication phase, then to an uptake, and then finally an impact. Where Radiant is focused is within that red basically circle here, or almost oval, which is on the publication and uptake. So our mission is really providing those infrastructure and APIs for easy publication and discovery of the data, and also making sure there is enough mechanism, incentive, and connection for the uptake. We definitely work across the 4 phases here. We work with other organizations in the collection and the impact kind of categories, but our main mission is focused in publication and uptake. And we do this with being an open and innovative organization. We do collaborative work, and we leverage our neutral basically position. Being a nonprofit helps us being kind of a convener, bringing other players into this ecosystem from both commercial and non-commercial sector, and try to do this in the best way, providing standards and best practices. Many of you might be familiar with the machine learning cycle. So in this cycle, you usually have particularly with the supervised type of problem, a set of training data, which is usually some sort of label. In this case, I'm showing labels of satellite imagery with some like building footprints. Then you train a model, you have a trained model, and you deploy this to do predictions across other regions, other times. And then you start doing performance evaluation. Does it address my need? Does it satisfy my requirement, basically? And you have some insight into the performance of the model. And from there, you or other groups may go into improving that model by adding more training data, changing the architecture, and going through the same cycle. So this is a continuous effort. It is not a one-time thing that you just do some prediction and analysis and you are done. The key feature here is to make sure we can document and publish this cycle correctly and in an accessible and reproducible format so others can really adopt it and easily use that. And there are many challenges in there, particularly when you think about geospatial data, there are challenges in there. Broadly speaking, and this is the kind of outcome expert workshop that Radiant hosted with support from NASA in 2020, about what are these challenges when we think about applying ML broadly to earth science, but particularly to geospatial data, which can be satellite data, can be drone data, can be kind of points data from cell phones and other devices. You can think about issues in the training data ecosystem, which is, we need better benchmarks. We need open access to those. And we need to also think about how we use like synthetic training data. There are issues in the model development, thinking about how we better incorporate physical constraints into those, or how to think about better architectures for those. And there are issues in terms of how we do documentation and sharing, which comes to the discussion about repositories and the webinar today, which is about standards and repositories for sharing to facilitate the kind of input to that repository. So someone who has published the training data can easily share it, and those who are consumer and user can easily access and discover it. And also mechanisms around incentives and investments, because there is an effort to do that. It is not free to publish the data. You need to invest time into document it, putting it in the right format, and then publish it. So who should support that? There's a lot of discussion around this, and we published an article about this. If you're interested to read more, you can go to this AGU EOS advancing AI for earth science. So today I'm going to talk about what Radiant is doing in the ecosystem of training data and documentation and sharing. And there are good examples of benchmarks outside of the geospatial earth science kind of ecosystem. I think those of you who have worked with ML models are definitely familiar with ImageNet, the very first kind of computer vision training data that was published back in 2010. And then others like COCO, Cityscape, and many others that I'm just showing 3 examples here. If you look at what is common across them, you see them, first of all, published in a ML-ready format. So as a user, you don't need to do much pre-processing. You can easily read the data in any programming environment you're focused on and start building your model. They are very well documented. You can easily track back how it was generated. They are regularly maintained, meaning that it is not just one-time publication. You see continuous improvement in the data. If they learn there's like deficiencies or biases in the data, there's new versions coming out. And there's a good train test split, particularly when you're building an ML model in the benchmark sense. You want to know, okay, what portion of the data I should use for building my model, what portion I should use for evaluation. So these are all very well defined in the benchmarks. In the geospatial sector, we haven't done much of that, and that's why Radiant established Radiant MLHub, which is the first basically open repository for these geospatial training data. And our focus and mission is really to bring this open ecosystem to address the lack of these benchmarks. In terms of the data generation, we do some of that ourselves, but majority of the data are actually provided by the community. We are facilitating the way they generate the data and they publish the data. MLHub is also, broadly speaking, not just a hub. It's basically 3 pillars of activity. I mean, the first one is definitely the hub that I just talked about. We have now multiple training data sets, more than 24 or so. We are soon going to launch a model repository, meaning that you can query and search for existing pre-trained models that would work with Earth observation and geospatial training data. And we also run competitions and data annotations on these data. So we work across the ecosystem. The second pillar is the community and the user, basically. We work closely with them to see, okay, what works, what doesn't work, what are the best practices, how we should change these things, and providing those as either on standardization, which is the community agreeing on, or as a guideline and a best practice that people can adopt. And we also think about a lot about interoperability because we have too many diverse types of data. So how can we better kind of store them to be more interoperable? And last but not least, it's about education and market information. So we run trainings and tutorials. I'll talk about them more toward the end, and also sharing the best and the latest kind of advancements in the market as a monthly kind of newsletter thing, and also webinars and speaking engagements like today, so to disseminate basically the information across the community. On a technical sense, this is what is the infrastructure of MLHub basically. So datasets sit on a cloud environment, and we are agnostic in terms of what cloud ecosystem we host the data on. The key piece is having a standard catalog of those data. So that the data storage is federated basically. Then we have these standard catalogs, which are based on Stack. I will mention Stack in the next slide, but it's a standard way of basically storing your metadata. And then we have basically a standard API and authentication for accessing the data. It's open access, so anybody can sign up and start accessing the data. The authentication is just a way for us to see how much the data is being used, which data sets are more used, and so on. So it's a way of collecting some of those statistics, but otherwise anybody can sign up and get an authentication. And in terms of access points, you can use our public API, so write your own code and a script to access the data. We have a Python client that enables you to search the data based on their DOI, based on their names, just see what is available out there, looking at the whole catalog, and also downloading and easily basically bring those data to the Python environment. And we also have a web portal. I will show a GIF from that you can basically scroll the web and just download the data right from there without need of any coding experience. I mentioned Stack, or Spatial Temporal Asset Catalog. This is basically the standardization that is powering MLHub. It is a way for basically storing your metadata in terms of what is this geospatial asset that I'm storing on my catalog, in this case, MLHub catalog. It's a very kind of simple JSON-based kind of metadata specification. It's static catalogs, and it has also an API definition. For those of you who are familiar with the kind of geospatial ecosystem, you might be familiar with OGC, the Open Geospatial Consortium, which has worked on many of these standards in our industry. And Stack's API is compliant with OGC. So we are building on top of basically OGC's features API and enabling an ecosystem of these standards. And Stack was something that Radiant convened about 4 years ago, bringing various players and kind of members of the community to work on this problem, that how can we better as a community catalog our data. And as part of that, we have also developed a label extension for Stack, which is for training data sets. When you have a geospatial training data, how you would store that, and Stack is basically addressing that. And it's an open source and community-driven specification. If you're interested into contributing to Stack or adopting it, I will have the links of our website at the end. You can definitely join and be part of the community. So this is a snapshot of how the website access looks like. This is MLHub.earth. You can see a map of the data sets. Each of these cards is basically a simple data. You can filter them by different keywords and tags here. This is, for example, a crop type data in Central Asia. When you land on this page, you see the description, you see the DOI of the data. Each of the data sets have a DOI, and then basically reference, whether it's a paper published in the community or another publication that the data provider has provided. And then ways of easily downloading the data, which is on the right side of this. When you see this, you can click here. After you sign in, you can download the data. We also have a code snippet if you go to the Python client, how to access the data. So this is basically the UI for you to access the data. And as I mentioned, you can access through the Python client as well. Another kind of snapshot of what data sets we have. So we say geospatial, but what are the applications? Most of our focus has been on crop type, actually. If you look at the number of training data sets, we have about, I think, 12 or 13 of them, which are all crop type. And this is because of the impact that agriculture has across the development sector. But if you look at the geospatial distribution, we actually have data sets that might go broader than the crop types. For example, the land cover, we have one from Land Cover Net, which was a data set Radiant actually published, and that covers most of the African continent. And then we have others in the US and Europe as well. We have data sets for kind of high resolution detection of cities, roads, and buildings across different AOIs, areas of interest across the board. Oh, sorry. And also data sets about natural disasters, particularly fire detection, storms and flooding, again, across various countries and regions around the world. This is a growing catalog, so we regularly add new training data sets, and you can follow our social media to get updates about what data sets are coming up. But this is basically an status of what is in the catalog right now. And all of these are basically labels combined with satellite imagery. So it is a ML-ready data that you can start consuming and building model on. But what is next? I also mentioned the model catalog. So now that we have the training data catalog, the other piece of this puzzle is the ML cycle that I mentioned at the beginning is a cycle, and we need to capture how we are doing or how we are basically producing our model. So if someone is picking up on a model, for example, I developed, they can first of all reproduce my results or just reuse that for another application, whether it's a different training data sets, whether it's using that as a pre-trained model and kind of fine-tune it with another training data set they have. And this is looking at the cycle of, we have the feature engineering and model development, again, the deployment and maintenance of that model, and doing that basically exploratory data analysis. So to do that, we are working on something called a model, machine learning model catalog, particularly for geospatial data. This repository is going to move soon to another one, but it's still active if you go to our GitHub Radiant Earth, the GeoML model catalog. So this is a similar effort to the Stack that I mentioned. We have convened various members of the community, and again, it's open community, so all of you are invited to join if you're interested, to see how we can catalog our models. If we have, for example, supervised classification of roads on Sentinel-2, which is the European Space Agency mission satellite data, how can we catalog and record, okay, this was the image I used, this was the training data, this was my training environment, what Python package I used, what other kind of elements of that, what is the performance of that model, and where the model can be applied. If I train my model, for example, in Uganda, can I apply it in Rwanda? What is the developer's basically assessment of that? And then providing that as a information to a user, so a user can search against those metadata. That is the purpose of this catalog and specification. And at MLHub, we are going to launch our first basically model catalog toward the end of this year. So look for announcements around that. And the end goal vision is really MLHub being part of a larger federated ecosystem of repositories for these training data and models across the geospatial sector. We are not thinking about MLHub as just one repository. There will be many of those, but they are interoperable. They work with each other. They talk the same language in this case, which is Stack, and hopefully GMLMC, which is the model catalog. And a user can go to any of these and start searching and discovering those data and models based on their search criteria, whether it's a spatial bound they're looking for specific data or time, or any other like application tags or things like that. So, and that's where we are pushing the ecosystem forward to have those federated data repositories and model ones. I want to finish with the fact that this is not just about data. And we have a community of practice. So last year in 2020, for example, particularly with the impact of COVID, we moved all of our events and trainings to virtual format. And we had more than 1,000 participants actually in our workshops. For example, we had the Computer Vision for Agriculture workshop as part of the CVPR conference. We also had a kind of full day cloud native geospatial outreach day talking about various technologies and best practices of doing geospatial data on the cloud. And then throughout the competitions that we launched and we hosted, we had more than 660 participants working on these data sets, building solutions. I mean, there was a competition, so they were competing for the prize, but at the same time, they were learning and kind of exploring how to use this data and how to build solutions. And this is a key effort on our side to make sure there's adoption, there's capacity development, and there is learning throughout. Another example of that, which you will hear more from that today, is a training of trainers bootcamp that we hosted earlier this year in actually May of this year. We had about 40 participants from 4 countries in Africa. This was a workshop supported by the Fair Forward program, which is an initiative from the GIZ, one of the, I would say the founder of the Open for Good initiative. And we had various types of lectures and modules around how to use remote sensing and machine learning. And the focus was also on training of trainers. So we are training a group of individuals who will become trainers in their community and go out and train others. And for that reason, we also had a module on teaching practices as well. One of those participants is Renate, that you will hear from her after my presentation. So the materials from this training is also all available on our website and our GitHub. So feel free to access that, as well as on the Atinji website, which is an online course material platform developed by the GIZ and partners. With that, I would like to thank you for joining us today. These are the links for our Radiant website and the MLHub website, both of them radiant.earth, mlhub.earth. We also have a Slack community, which is an open community of our users, basically chatting and discussing with each other about different topics and questions related to ML and EO. So feel free to join that link. We'll put it in the chat so you can access it and ask questions or just learn from others or share your experience. Thank you, and happy to take any questions.
Thank you, Hamed. I'm looking around. I don't see any questions in the chat. I also just checked the Slack. I'm sorry, not the Slack, the Slido. And I didn't see any questions. I think I was so excited to see you have a Slack channel. The word Slack is stuck with me. So I'm looking around, and in case anybody has any questions, would you like to type them in the chat or share them otherwise? And in case you don't have any questions, I do have a question for you. So again, with the Slido, yeah, I see somebody greeting you, Hamed. So greetings from one of our participants.
Yeah, hello
and I'm looking forward to the question that they're going to pose. And yes, what is Radiant's science mission?
Good question. I mean, we are, I won't say we have necessarily a science mission. We have a technology mission. We are focused on enabling individuals like you who are working on, let's say, an agricultural monitoring problem or a land use change kind of monitoring system, or on dashboards for biodiversity and conservation practices, to be able to use ML and Earth observation for building that solution. Because many of these satellite imagery and Earth observation are open access, particularly those operated by the government agencies like ESA and NASA. I mean, we have now in Africa also space agencies thinking about launching their own satellites, and also the Indian Space Agency and the Japanese one. So there are open data out there, but they're not free. You still need your technology to access them, right? You don't need to pay for the imagery, but you need the skill set, you need the infrastructure to access them. So our mission is, how can we help individuals and users to better access those data, build solutions, particularly with advancements in AI and ML, and then help decision makers and policymakers on the ground to be more effective and address many of those challenges. We are not going to build the solutions. We don't see that as a long-term sustainable way of doing that. We want to empower individuals to do that in their community. So that's how I would kind of play our mission. Talked about attack, yeah.
You're on mute, Elizabeth.
Elizabeth, you're on mute, yeah.
Yeah, this is the thing about making good practice and then you forget. Thanks, Ahmed. I see a question from Tyler, and he's asking if you have any suggestions on the kinds of training examples that are the most helpful. Is it hands-on tutorials, code examples, Jupyter notebooks, or something else?
Definitely. I will post the link from our GitHub repository. So we have a set of Jupyter notebooks for those tutorials. Those mostly are focused on how to access the data from MLHub. And in the case of the competitions we have launched, we also have like a baseline model Jupyter notebook, how to go after building your first model using this training data set. So all of those are on our GitHub repository. And I think they are the best and the most kind of effective way of learning them, because it's literally hands-on. You see the data in practice, there's the code there, and you can consume those. We also have a series of webinars that we talk about some of these in a more like lecture format. That's on our YouTube channel. I think my colleague, Luisa, our colleague, is putting the links in there. So check those out. And then there's the bootcamp that I just talked about, which has 11 modules about different ways of how to work with geospatial data, some introductions to AI and ML for those who might not be familiar with that part of the problem, and then how to use them in a use case format. We had land cover classification problem, we had crop type classification, we had a tropical cyclone one. So you can see different examples and use cases of those in that kind of training program as well.
Okay. I see two questions which I'm going to pause, and then we'll take the next set of questions after we speak to Renate. So we have one from Ernest, who's asking what the refresh rate for the data is. And we have one from Victor, who would like you to explain again how the process works. If he collects data with a drone, how does it move to a GIS layer?
Okay, the first one is easier. Let's take that first. The refresh rate, it depends on the satellite. So the best, so first of all, I'm talking about imagery in the sense of optical data, because we also have radar satellites. But in the optical world, the highest refresh rate you get from open satellite data is every 5 days. So Sentinel-2, which is the European Space Agency satellite, provides an image of everywhere on the Earth every 5 days. If you start using commercial data, then you can get daily imagery actually from the Planet company, but then you should pay for the imagery or have some relationship with Planet to get like academic license or something to get those imagery. So that's the refresh rate. In terms of how you go from a drone image to a GIS layer, that's a very technical question, but I'll try to get to as much of it as possible. So that's basically what is a kind of a geospatial analytics kind of portfolio, right? So with the drone, usually you get an image and then you get all the metadata about those pixels, where they are located and things like that. There is usually a pre-processing from the drone. So to mosaic those images together, you usually use some Python package to do that. And then after you do that, you can basically in Python export those to any kind of GIS layer you want, whether you want to extract specific features from that, put it into a vector format, or just do a raster layer and then import it in any GIS application, whether you're using QGIS or ArcGIS. you can do that. So the process is pretty much standard in terms of how people do it, but it is some geospatial processing and coding in there to be able to do that. Yeah.
Great, thanks, Hamed. We will be coming back to you with more questions. So Hamed is still here. If you do have more questions, please post them in the chat, or go ahead and go to Slido and use the question and answer function in Slido, and I will be monitoring that, and we will pose the questions to Hamed before we leave. I do want to now invite Renate to switch on her camera and be ready. And she is a graduate of the Bootcamp, and she's going to be telling us a bit about that. Before she starts speaking, I just want to draw your attention to the Slido question which I posed, and just to show you what our current results look like. How many of you had heard about Radiant Arts ML4EO Hub before? So far, only 4 people have participated, and 3 of them had heard of a hub before. So I'm looking forward to more responses. Yes, it's changing, 8 people now. Great. So I'm going to keep that open and look forward to seeing how this changes as we go. Had you heard of it before today? But in parallel, I'm going to invite Renate. Welcome, Renate. Thank you for agreeing to be our guest today.
Thank you for inviting me.
Great. So I like to get people to introduce themselves. So I'm going to give you the moment and let you tell us a bit about yourself.
Great. So my name is Renate Thiede. I'm from the University of Pretoria in South Africa, and I'm currently working towards my PhD in statistics. So please think of me in your prayers. I have quite a strong background in geoinformatics and a little bit in remote sensing.
Thank you. That sounds interesting. I remember when I was young, we were told that PhD stood for permanent head damage. So I'm hoping you're not going to suffer from that. From your experience, what are the needs of the remote sensing ML community in your context, especially for people who are getting started on their ML journey?
So for that, I would say training, education, that's really the big one. Too many people can see ML models as kind of a black box. So training and also data, especially knowing about, where to access data that's free in terms of cost. And also, as Hamed mentioned, how to access data. So, there could be data available, remote sensing data available, but really connecting the dots in terms of the education, how to use the models, that's the general need.
And what were the main advantages of attending the ML4EO Bootcamp as relates to this for you? The
training, just getting such a big overview of different ways of approaching remote sensing problems. It was mainly sort of crop classification kind of problems, but also some weather and climate related problems. Just seeing all the opportunities, all the options was great. And also being exposed to not only the data that's collected in the catalog, but learning how to access that data. That was really a big step, and it opened some doors for some of my trainees.
Wow. How did you present the bootcamp to your trainees? How did you get them to know more about it?
So there was a lot of interest, which actually surprised me, given that most of the people that I marketed to were other statisticians. So that's interesting because typically statistics is associated with finance and that kind of application, but people were really interested. I ended up having 9 trainees. Only 2 of them were from the GIS side, and they also didn't have much remote sensing expertise. So it was quite new, and it was really amazing to see the interest in this field that's from people who don't have a background in remote sensing necessarily, or even in Earth observation at all. People were just really interested. So it was the people who ended up attending were mainly masters and PhD students in statistics, and one associate professor actually. So it was really cool. I presented the training to them. It was online as well because of COVID. We worked through the materials of the bootcamp, and it was really amazing just to see all the discussions that we had. Things that I hadn't wondered about in the bootcamp that I just I thought it was straightforward. And then my trainees would ask me something, and then, you know, we'd have to rethink, how does this concept work in remote sensing or even in machine learning?
Wow, so it triggered a lot of thinking and a lot of reflection. Did that help with your results?
Well, yeah, I really would say that it did. It made me sort of rethink some concepts and have to relook at things, especially in terms of remote sensing. It was quite interesting to be the one in the room who sort of knew them the most, largely as a result of the training. That was new for me in terms of remote sensing. And yeah, what it really helped with was one of my trainees who was actually doing her master's in statistics, but as a result of this training was able to use remote sensing data. So she's investigating the effects of sampling, how you sample your training data and what the effects are on the results. And she was able to participate. She wasn't able to complete, but she was able to participate in the latest competition, the Spot the Crop Challenge, hosted by Radiant Earth. And as a result of the data that was made available and all the resources, both from the bootcamp and from the competition, she really made great strides towards completing her master's. So that was amazing.
Wow. Do you have any other stories of other trainees who were using this data in interesting and amazing ways? I'm just amazed that you can use this to evaluate how sampling affects your results.
So far, I don't have any other testimonies, at least none that are that cool. But I do have one of my own, which is that before attending the bootcamp, I had never heard of Stack. I had no idea what it was. And in September, I was able to attend a spatial statistics conference. And they started talking about Stack and how to use it with R. You know, that there are some R libraries that allow you to use Stack APIs and so on. And I wouldn't have known. I would have been completely lost without the background of the bootcamp. So the effects of this training and these opportunities are really much more than even just within the remote sensing community. It's also spiraling outwards into the spatial statistics community and more broadly.
Wow, great. What is your parting shot? What is one last thing you'd like me to share with the participants?
Well, I would say, honestly, the focus that Radiant Earth has on the developing world and especially on Africa is so amazing, because in the research community, it feels, maybe this is subjective, but it feels like we're not seen. You know, so much training data and so much expertise seems to be focused in the global north, and we sort of feel left out a lot of the time, or unable to participate in research, not because of a lack of expertise or a lack of motivation, but simply because we don't have the infrastructure in terms of the data or the training. And this is just such a great step towards being more inclusive and equal. So I'm really grateful for that.
Thank you. I see something has come in for you. So Ana Cristina Fernandez says, good luck with your PhD, by the way. And then she does have a question. Do you have any future plans to apply the knowledge you acquired after your PhD?
Absolutely. So I'm planning to remain in academia. So I will use these skills for continued capacity development. We've actually got more students that are moving into a sort of spatial and remote sensing realm, even though they have a statistics background, and then combining that with ML and AI. So I would really love to continue to help training them and preparing them for the workplace.
Thank you. Does anyone else have any questions for Renate before I let her go? Great. So I don't see any more questions or comments coming in. Thank you so much for sharing your experience with us. And I really love the cool story. I'm inspired to consider the course. I mean, I have no idea how Stack works. So it might be worth it for me to look at it.
Absolutely. And it was a lot of fun, and really Hamed and the organizers were also supportive. So I would absolutely recommend it.
Thank you so much for your time today.
Thank you.
Okay, so I see Louisa has shared also a link, I guess, for those of us who need to know what Stack is. Thank you, Louisa. So I see a link in the question and answer. And in the meantime, I am looking around to see if anybody has any comments, any experiences they'd like to share, any questions. And if not, I am again going to share my screen and just let you see what's happening in the Slido poll. And now 12 people have let us know whether they had heard of this before. And it's an 85%, 15%. So actually, people in this meeting are quite informed about the ML4EO Hub. Yes, it's changing. More and more people are participating. I like it when it changes. So I'm just going to give it a minute, just in case you still want to participate in this poll. And then I'm going to try and understand a bit more about you as one of our participants. So would like to know a bit more about your background and whether you find this training offered by Radiant Earth interesting. We will be using Slido for that, so I'll definitely let you do that. In parallel, I am checking the chat function to see if there are any questions. Yes, Victor would like to know, so I think this is a question for Hamed. Do you plan to organize another bootcamp, please?
Yes, I mean, I don't have the specific dates for that, but generally running bootcamps and trainings is going to be a key activity for Radiant team. So keep an eye on our social media and also sign up to our newsletter. You will hear about that as soon as it comes up. So, I mean, in the next 2 months, I don't expect, so it's not going to be 2021, but definitely in 2022, we will have another bootcamp and training with a similar focus, but maybe a different geography in Africa. So short answer, yes, details to be announced. Yeah.
Great. And I also have a chance where you can let us know if you want to have more information on the webinar. So, I mean, on the bootcamp. So I'm going after this webinar. So I'm going to move to the next poll so we can get to that as well. Okay. I see some questions on Slido. So I just launched the next poll just to try and understand a bit about you, your background. Is it technical? Is it EO-based? Is it international development? Please feel free to let us know which one it is. And in parallel, I see 100% international development. In parallel, I'm going to check what the questions on Slido are and let you know. Yeah, these are questions more again for Hamed. Does Radiant provide access to cloud-based computer processing for custom model training or ML deployment?
So no, we don't provide compute resources. I mean, and honestly, the reason is that can be unlimited, right? So as a foundation, we can control that. But we work with many of the cloud providers, both who work on kind of geospatial applications like Digital Earth Africa, and those who are like agnostic cloud providers like the Azure service and the Planetary Computer from Microsoft or AWS resources, to make it easy for you all to basically use those resources. So if you're interested in some, like I would say, sandbox model, entry level, without cost, kind of cloud resources, I would recommend checking out Digital Earth Africa platform. They have these kind of virtual machine instances on AWS Cloud that you can easily start consuming geospatial data without paying anything. It's a small machine, but you can start playing with toy models, small use cases, and see how it works. Planetary Computer and Microsoft Azure is doing a similar thing, so you can sign up for that and start using the data. And with the partnership we have now with Microsoft AI for Earth, you will be able very soon to consume MLHub data within Azure ecosystem without the need of an extra kind of authentication or going to another API. So we are within the same ecosystem. You can easily see the raw satellite data as well as the training data from Radiant. So we are building those integrations, but we don't compute resources ourselves.
Okay, great. What ML for EO applications are there that benefit end users?
What ML are there that benefit? So, I mean, in terms of applications, I think there are many that are not necessarily directed for policymakers. I mean, thinking about, for example, many of the agricultural applications, that can be a product that a commercial company wants to build and deploy to the market. It is not something about policymakers. It's like providing a recommendation system to farmers in terms of if their crop is impacted by specific disease, or if you want to do crop yield forecasting into the growing season and then providing suggestions to the farmer whether they should irrigate the week after or they should wait until, for example, the rain comes, and kind of integrating some of the weather data into those. So those training data definitely help with that. In terms of the kind of infrastructure and road and buildings, that can be again be used to build many kind of data about, oh, how is the ecosystem changing here? And that can help with many of the climate change solutions, like, oh, are we changing the surface from like the natural surface to more impervious surface? How does it impact the flooding and downstream kind of impacts on the urban development? So there are many applications there, yes, that are not necessarily targeted for policymakers, but they can be for like commercial products or even individuals just trying to see how this data works, just to solve a problem. So you have a combination of both, yeah.
Great, thanks. I see Louisa has posted some more links. Thank you. And Jonas as well. I think this is a general question. Can third parties add training datasets to the ML4EO Hub? And if so, how can they do this?
Yes, so basically anybody can add training data to MLHub. It's an open repository. The adding of the data is not automated yet, so if you go to mlhub.earth, you see a sign up form there that is submit your data. There's a questionnaire. You tell us what is the data, how you collected it, what is the type of data and everything, and then we will contact you to receive the data and host that on MLHub. We are going the direction to kind of semi-automate that you can literally submit your data through an API. But for now, we are doing this in a kind of a manual sense to kind of be able to scale it gradually. But short answer is yes, you can do that, and the form is on mlhub.earth.
Great, thanks. I think so for now.
Submit data, I definitely know that. Do that, please.
Definitely. So far now we have 73% technical people in the audience and 27% international development. Very interesting composition. What we would like to know from you is you'd be interested in attending a Radiant Earth Training of Trainers program yourself. So it could be a yes automatically based on the high recommendations we received today, and no, or maybe you need a bit more information. So whichever it is, do let us know. Meanwhile, I still go back and check in the chart. Yeah, I see we're now at 50-50. Just in case there are any new questions. No, I see Louisa has put them in, but no. Okay, great. So it seems that we provided quite, where I come from, they say absolute silence means absolute comprehension. So we provided quite a comprehensive exposition of a subject that everybody understands perfectly and they're happy with the information, and 60% are actually interested in attending a training of trainers. Well, 60% of those who have participated in the poll are interested in participating in a training of trainers. While they are thinking about this, I'll ask you, Hamed, if you have any parting shots for them. If there's only one thing that you'd like them to think about as they leave this webinar, what would that thing be?
Honestly, the final comment would be geospatial data is a horizontal sector. You can work across many applications. with geospatial data. So I see it as a skill set that can benefit you and the society and the community at large down the road. So if you're looking for new areas to learn new things, be more impactful, I encourage you to tap into this ecosystem. We have a lot of resources for you to learn and build solutions and change the world. We have many problems, including the climate crisis. So if you're passionate about solving world problems, there's a lot to do in the geospatial world, and we would love to hear from you if you need anything and how can Radiant help you. So tap into this, and we would love to see you engage with our data.
Wow. Okay, lots of things to think about, lots of contacts to use. I see in the chat. Thank you, Jonas, for posting the Open for Good website. And to contact the Alliance, you can. There's an email address, fairforward@giz.de. Thank you for sharing those. I don't see any other questions, and so I'm just going to invite all of you who would like to participate in a training of trainers to participate in the next poll. I would now like to invite Jonas, if you have a few closing remarks to make at this point.
Thank you, and nothing more to say than just really grateful for the great contributions, and obviously also the endorsement from for the Bootcamp program and the great presentation from Hamed, and of course all your contributions in the chat, the questions and the interaction. We're really happy also to have you around in the webinar series and invite you to stay tuned. You will automatically be also informed since you have all signed up to the event on our next upcoming webinars. So thank you again, and I think we can give ourselves the pleasure of maybe taking 5 minutes or going out 5 minutes early on our busy schedules. And yeah, over to you, Elizabeth, for closing this webinar.
Great, nothing much to add. I will take it from you. Let's have 5 minutes to breathe before we have to jump into the next webinar or activity. Thank you everyone for your time today. It was great hosting you, and we look forward to seeing you in November.